So I managed to gently crash tool changer without this turret on tool changer when I was from other side of machine and had MPG in my hand and was moving first in Z axis, and I moved to the farthest left, to the most left position, and then I got idea to check what is going on when I'm going to X and when I'm going in X direction down. And as this was removed, I managed to come all the way here and imprint inside this is metal ring. I managed to imprint in this, so as motor have overload protection, it shut down the motor, but even with protection I managed to make mark in this round plate, so I have mark from this. And anyway, I wanted to show what this is from some printer or copying machine, 16mm round bar, and I bought this magnetic hydraulic holder for instruments, and it is the biggest, so I never use it for assembled machine. I use it when there was no plate, so I was able to put magnetic stand inside behind this panel. So this is how it looks now when its machine is assembled. And other thing, I'm not sure is this good to have magnetic field behind bearings. Maybe they will magnetize balls or something, I don't know. Anyway, this is the most rigid place where I can clamp holder. And now I need to go for stand. So this is camera on stand, so I need to use two hands for MPG, and so now I need to check is tool changer parallel. I know it's not, because like I said, I managed to crash on spindle. Also I will need to check is this collet chuck out of center, because I also adjusted runout to be minimum. It holds with 6 screws, so maybe this also is pushed down. So now I will check tool changer. So when it rotates to right side or clockwise, that means that it goes so this is the maximum that I can go right, and it falls down. So that means that this bar stands like this. It does not stand parallel with axis of rotation of spindle, and it's not parallel with this axis with Z axis. So what I need to do first, I need to lower this I need to take imbus key. I need to loosen those 4 screws, so I think that it's pretty big force. I think 200 kilos or something like that. So like I said, it was like this, so I need to put it a little bit down. And let's see what, maybe it's now too low. Okay, Z. So it falls down. So this is the far that I can go to right side, and that means that I need to adjust instrument a little better. So what is good with this holder, I can just unscrew this one point and that's it. That's it. Also, we'll do this. So, maybe it will be easier with smaller holder, but I bought big one. I thought I will manage to use even the biggest. So when I do this, I think it will be okay. So now I want first to go down to release pressure on instrument. So down is, this is down, okay. Okay, and now Z. So it goes slower. Now we'll go, no, this is high, this is low, high, low. That means that this is in this position instead of this position. So I need to tighten a little bit screws because I see that it falls down. So let's see now what will be result. So goes down, goes up. That means, let's see now. Goes down, goes up. Okay. So I need to check this on 60 mm of distance, and tolerances are 0.03 millimeters on distance of 60 millimeters. So this, is it possible to see? Is it possible to see? Is pretty good. And now I need to tighten screws again. And the thing is that something will move probably, so we'll need to check again. So I was careful when I was trying cam, and I had few almost crashes, but I always had my finger on e-stop button, and now when I was behind the machine I did not expect something to happen, and I managed to crash tool changer in spindle. So, but of course spindle was not rotating, so it was not so ugly, but I was really surprised that I did something stupid like that. So this looks, I want to check on a little bit bigger range, so I need to somehow, so I can do something like this. I can do something like this. Oops. I can do something like this. I wanted to buy Noga holder, but as I needed this holder as soon as possible, I needed to buy in pretty much local store, so it's pretty good, but probably Noga is better. So this is it. This is it. This is it. Now we'll check on greater distance. So first need to go down. Okay, now z-axis. So this works, okay. Now I need to be careful not to plunge this test bar in spindle. But is it possible to see tool changer is parallel with z-axis? It's parallel with z-axis, and that's it. And I can show what is reversing play. So need to, this is 6 and I'm moving for 0.1 millimeter. 0.1 millimeter, yes, for 0.1 millimeter. So let's go from here. So I'm moving for 0.1 millimeter. And now I want to move up, and it looks that reversing play is 0.01 millimeter. No, down, up, so let's set on 0, and now I will go down. That is all nice, and I go back. So it depends how precise instrument if you using. If you use 1 micron resolution, then you can see a little better, but for x-axis this is pretty good if I consider in how bad conditions are ball screws. I can only imagine what would be result if machine is new. So let's see. Down, I'm going down, so I will go for 0.01 millimeter down. Now I will go up. So according to this instrument, reversing play for x-axis is 0.01 millimeter, and that is really good. That is really good. So this is it. Now what is left to do? Now I need to check tailstock, so I will stop recording because I never did that. I did this already, so I know procedure, so I can show pretty fast. So when I do something that I never did, I usually spend battery very fast. So this is it. So one more time to check parallelism. So it's okay. And other thing, you can use the biggest holder, and like I said, I do not know is it good to clamp it on spindle, but that is pretty only place where I can clamp it. Oh, for adjusting tailstock I need test bar that I can place between center of spindle and between center of this, and I need to go with tool changer left, right, and probably instrument needs to travel on that, and I need to have 0 movement of instrument. So as I do not have that, I will leave it in this position and I can return back glass. And that's it pretty much. I bought a LED light, so this is how it looks. This is how it looks. It is equivalent of 100 watt normal bulb, so it's pretty good, and it consumes 15 watt of energy, and the effect is like it's 100 watt of classical bulb, so it's pretty good. pretty good. And good thing is that I can see very good with this light turned on what is going on behind the machine. So it looks like mess, and to somebody it is mess, but for me I know what is what. So now what I need to do is to install fan for cooling, and need to install some control that I can turn one switch and to engage all power supplies. Thing is that it happens that my main fuse is triggered, so I cannot turn on all consumers in same time. So this is my electrical cabinet. I assume that spindle, that quality chuck, was lowered down as when tool changer was going down on nut, and so this is what I have now. And I adjusted quality chuck to have minimum runout. So now I have 1, 2, 3, 4 multiple 0.01 millimeter. And now I will need to unscrew this, remove nut and loose those 4 screws and adjust it again. So I had 0.04 millimeters runout. After I think 20 minutes of adjusting, so resolution of instrument is 0.01 millimeter, and I measured here in this point and in this point, and the best result that I can get is 0.01 millimeter, and it was 0.04 millimeters. So this is good enough for my needs. So conclusion is that definitely tool changer moved this from spindle, as this was pushing down until drive overall protection functioned. It managed to push it down, but luckily nothing is damaged on spindle. So I have trouble with my tripod. Let's see, is this enough for this baby? No, it's not enough. So my battery is for garbage.